Welcome to the Bak Up Podcast, a show on how technology is changing the way we live and do business. I'm your host, Ioannis Bak-Bakagiannis. Bak Up is ready to start. Hello. This is episode 7 of the Bak Up Podcast. As you can see, if you're watching on YouTube, we're in our summer mood and no virus can stop us. Our guest in this episode is a brilliant machine learning researcher and a great collaborator. He holds a PhD from Western University on mathematical physics, where he worked briefly as an assistant professor. Currently, he is part of the RBC family under the umbrella of group risk management, where he is working on the validation of statistical and machine learning solutions. He is Ali Fathi. Ali, welcome to the show.
Oh, thank you very much. Thanks for having me.
Great. I tried to give some background information, but I feel that you can do a much better job than myself. Can you share some insight on how you found yourself in the position that you are right now? And especially, how did you get into machine learning from a physics and mathematics background?
Yeah, sure. Right now, so as you said, we are part of the RBC Global Risk Management. And by definition, this large team oversees the risk that arises but as a result of the way the bank does the business. We are a tiny part of that big group, and we're focused on basically the various aspects of risk that arises from deployment of AI technologies in the bank. So that could be at the algorithmic level, for instance. That could result in failures of our models, or not understanding actually the complexities inherent in those models, and also from the operational view. So these are the kind of aspects we're focused. In terms of my journey, I actually did a mixture of geometry and physics. Actually, I'm a mathematician by training. My advisor was he had actually very strong interest in physics, so I did some math physics stuff, kind of mixed with each other. I think after finishing it in 2015, I think I finished my PhD with a head full of I would say philosophical questions in terms of what I want to do next. I think one thing was clear, and it was that I wanted to be more, the role I wanted to play in terms of my career, I wanted to be more extrovert. That was clear to me. And at the time...
so no academia then?
Yeah, in a way, it was interesting because as I actually worked toward my PhD, I realized to be a professional researcher, it doesn't necessarily mean that actually your job is very interesting. Sometimes as a professional researcher, you need to actually publish papers to maintain your position and everything. And those are usually they can be actually not very fun. Anyways, so yeah, at that time, I think joining finance industry was the kind of the path of least resistance. So I jumped to another 1-year accelerated program at Western with focus on computational statistics and finance. In 2016, I was in the market, and then I got a job with RBC. So that's how I actually got into finance from physics.
Interesting. So you were looking because you started doing this course in finance. So are you prioritizing finance at that point, or you had your spectrum open for any position, any data science position at tech company, startups, or whatnot?
I think actually 2016, about 4 years ago, still. I think data science boom had not happened, actually, I think. It was really, the kind of jobs I was looking for was mostly senior quantitative analysts or quantitative analysts. And these are really people who do orthodox quantitative finance type of things. However, I should say the program actually that I participated in as part of that 1-year master's at Western, I want to actually do maybe a little bit of advertising for people who are interested.
For sure.
It was a quantitative finance program, but it is actually part of Western's stats department. So it was really kind of like a a statistical finance program. So their approach was really to approach finance from the kind of a big data point of view. I mean, to people who are not familiar with quantitative finance, usually you approach quantitative finance, the traditional one, the one you see in the textbooks, from two point of views. So it's one part is capital markets. So this is like trading stocks, options, derivatives, bonds, and things. And so this is capital market side or trading book side. But the other side is the banking side. So this is like the banking book side of the bank. So this is like the mortgages, deposits, credit cards, and things. So traditionally, the capital market side is very math heavy, and the mathematics of it is very understood, and you can see it in all textbooks. The other side is very data heavy and data rich, right? You are actually on the you're working on the banking side of things, so of course you know better. So it's more data rich, but in terms of methodology, there is a lot less certainty, and so the methods are a lot less standardized. I think that program helped me to actually gave me enough tools to actually start thinking on the banking side. So I landed on the banking side. The work I joined was focused on the behavioral modeling of banking products, not the capital market side. And the statistical tools that I had already was actually kind of very suitable to start doing experimentations.
As I mentioned in the intro, Ali is a very close collaborator of mine. We work together on validating the machine learning models from the sales practices and conduct team that I am part of. Result of our work is the first validated natural language processing deep learning model in personal and commercial banking. Many people would not know or would have mixed definitions of model validation. What is, in your opinion, model validation?
Hmm, that's a very good question. I think the answer to this question would probably be is the holy grail that everybody is looking for. So I think everybody has a definition of it. Um, but okay, so let me think a little bit about what it is. In very simple words, I think it's really making sure that you understand the capabilities and limitations of the methodology that you're deploying, right? And I want to say you want to make sure that if you want to make sure that your model works uh, the way you want it to work, but also validation means that you as the owner of the model, you need to think about the scenarios where your model can fail. So that is, I think, the definition of model risk. So the more you understand, the more proactively you think about the scenarios where your model can fail. um, this means that you have a better understanding of the model risk of your methodology, right? So now, the more complex your data input is, the more complex your algorithm is. Of course, the scenarios that this kind of combination of these two can kind of result in a failure gets more complicated, right? So the model risk goes higher in a way, if it
And
makes sense.
I can imagine that what you're describing uh, probably scales not that well with size. For example, if you want to completely understand a model, not only a model, like a model pipeline, input output, the model itself, it's going to get harder and harder as the input output and the model space becomes bigger and bigger and
That's correct.
becomes more complex. Uh, how do you think? Because earlier in the day, earlier, I mean, 2000 before 2012, we didn't even have neural nets, and deep learning is an outcome of the past 5 6 years when it has been so prevalent. Have you seen a shift from the earlier, simpler statistical models to the bigger and more complex deep learning models? On how do you define model validation?
I would say generally yes, but it really depends on the context where you deploy your model. Um, I can, for instance, certainly say that in the field of behavioral modeling, forecasting, where you work with time series data, tabular data. Um, I don't think actually deep learning has been able to actually provide very kind of impressive success stories. But yes, if you're, for instance, thinking about like the context of, let's say, computer vision or natural language processing, oh, for sure. I mean, that's a no-brainer. I mean, so you have to the kind of state of the art tool is now neural networks, the huge ones, right? And that's the way you get results. I want to say, as it pertains to again model validation in the banking and finance space. Um, so yeah, I mean, in banking, for instance, people say we don't have many images, right? But we have a lot of documents, for instance. So there has been a spike in actually deployments of NLP powered models in the banking space. Um, so that actually so this has resulted in actually us thinking about, okay, so you have this very large scale kind of neural network models. What are and that challenge actually the kind of the orthodox ways of validating simpler regression models, for instance. How would you actually think about, let's say, a kind of a neural network model with millions of parameters if you want to, for instance, do sensitivity analysis on the parameters that you have learned? There are millions of them. Which one you want to actually um, start perturbing, right? So the entire notion, at least within the financial model validation of sensitivity analysis of models, gets challenged here. Like, what are the analogs in this context? And I think currently these are all actually open questions, specifically because we are actually taking these methods from other areas, and we are bringing it into the kind of finance world, right? And I think it is understood that actually finance and in general is a tightly regulated industry, and the kind of risk assessment you need to do on this type of methodologies might be completely different from where these methods actually born, right? Were born. These were born in a kind of in a tech sector, which has a lot actually a completely different kind of risk requirements, right? So so in general, my answer to your question is yes. I mean, of course, these are all very relevant challenges for finance sector. If these methods are supposed to be absorbed by the industry, these are outstanding, open, and very important questions to think about.
From you explained us that model validation is understanding the model risks end to end and trying to put some trust into the output of a certain model. Someone can say that your work is towards making the model trustworthy. Have you heard the phrase "trustworthy AI"? And what does that phrase mean to you if you when you hear the?
Yeah, I think actually the word has become fashionable these days. It's so again, I think it's kind of um, but again, we model risk people want to kind of say model risk is the other side of the coin. If you take care of your model risk, then you have actually a trustworthy model, probably. So if you actually shed light on various aspects,
That's a big statement right there.
it is, yeah, why not? We want to promote ourselves, right?
I will hold you
Yeah,
accountable for
yeah.
that.
If we don't, who is going to promote for model risk, right? So, but yeah, trustworthy. If you want to even approach it literally, I
Mhm.
think really means you want to trust that you understand the inner workings of your model, and it means that you're not going to be surprised by the outputs of your model, right? So you should have minimal surprise by seeing an input outputs of your model. So if you can maybe like um, if we can guarantee this, maybe you're also close to having a trustworthy. But of course, it can actually mean a lot of things, right? The thing that you want your model to do, right, changes
That's
from
exactly
context.
when I hear trustworthy AI, and I think most people that they don't belong in the AI sector, if they hear trustworthy AI, their mind would go, "Oh, we're avoiding Skynet right now. We're avoiding Terminators." right? That's the simplest approach to trustworthy. So we're working towards something that is human centric and beneficial to the humans. So the actual model itself, the intent of the model should be of pure soul, if we can put it like that. What's your opinion on the perspective that we're building Skynet right now and nobody controls it?
I think generally right now what we do as machine learning scientists and AI scientists, we are just doing curve fitting. So I don't think we are even close to actually the notion of general artificial intelligence. Um, I think just browsing through like a machine learning textbook, any respectable one, a kind of a seasoned reader could see that actually all we do is really more complicated, high dimensional, more nonlinear ways of fitting curves to points. So that can mimic the way we some aspects of human intelligence does, like for instance the way we understand images and text. But this is far from actually kind of general artificial intelligence. So that's kind of a word of assurance to those kind of people. Uh, I don't want to actually kind of again discount the huge breakthroughs of actually representation learning in images and in text. I have some actually view on this, the way it can actually revolutionize some aspects of actually kind of our lives. Um, However, back to trustworthy AI. It kind of reminds me actually to this metaphor that Ian Goodfellow and his collaborators coined as what is it called? It's called Clever Hunts. So they have a blog with this name, Clever Hunts. They call it Clever Hunts effect. And in general, what they want try to actually convey with this metaphor is Clever Hunts. By the way, was the name of a horse. And the owner of the horse would do some gestures, and the horse they would say a number, and then the horse would basically just tap like the legs and hands, like to show that he understands the numbers. However, then it turned out actually that the horse actually kind of sees other representations in the face of the person, and then understands he had to do something to get the treat. So what they try to refer to is that you might be thinking that your model has learned the stuff you want it to learn, but it might be that actually your model is right for the wrong reasons, right?
Mm-hmm.
And they
Yeah.
call this the clever Hans effect. And I think actually for them in the image domain, this was actually the beginning of the huge area of research called adversarial machine learning, right? So adversarial machine learning basically started with these observations that you think actually your model, for instance, classifies a dog because of the shape of, I don't know, like the face, or I don't know, a cat for like the shapes of like the ears. But then you see that these classifications or these decisions are extremely non-robust, right? So you can easily actually kind of manipulate them, and in general, I think decision making, non-robust decision making rules are not desirable, right? This is, I think, a principle of parsimony, basically, right? You don't usually inherent in the principle of parsimony is that simpler solutions are usually more robust decision rules. Yeah, I just wanted to also kind of maybe allude to this way of actually this way that computer scientists also think about actually trustworthy AI.
Yeah, and I like that you're tying in the counterfactuals and adversarial attacks. Maybe we can drill down a bit further down our conversation. But you mentioned robustness, and that's one aspect. So in the EU, like the EU, in 2019, put together guidelines for trustworthy AI. They claim that trustworthy AI has three components, which should be met throughout the system's entire life cycle. One, it should be lawful, complying with all applicable laws and regulations. Two, it should be ethical, ensuring adherence to ethical principles and values. And three, it should be robust, both from a technical and a social perspective, since even with good intentions, AI system can cause unintentional harm. Its component in itself is necessary but not sufficient for the achievement of trustworthy AI. Ideally, all three components work in harmony and overlap in their operation. Do you agree with this concept? Do you find anything missing?
Um,
I must say
what
this
are
is
the
this is the most highlight. They drill down into each part and they have phases lined out, but it's a bit too much to
Yeah,
unpack.
yeah, for sure. It sounds like a kind of the regulator language, the way they have to actually be sort of both exclusive and inclusive. Yeah, for sure. The one problem I have, and maybe this actually has to do with my background as a mathematician, with this sort of requirements is sometimes I miss the language of mathematics because it is so concise and clear. So if you have the background to understand the language, by reading the requirement, you can easily determine what is required and what is not required. The one, I think, problem personally I have with these kind of requirements is that the requirements are not even in many fields, they are not even either developed yet, or maybe more importantly, even if we have already like some orthodox norms in place for assessing some aspects, we are sort of ignoring this peculiar and very important effect technology has on norms and standards, and that technology actually tends to define new norms and bend the existing norms to its advantage, right? And in a way, when we're saying, okay, trustworthy AI should, for instance, adhere to such and such ethical standard or regulatory standard or lawful standard, the fact is that first of all, for a lot of applications, new applications of AI, I think we're effectively, I mean, the regulators are so, not just in finance, like in AI space in general, the regulators are so behind, to the extent that I think actually we human beings are just running a live experiment with AI, right? It's not like kind of development, right? You develop something and then you kind of deploy it. What we do right now, in a way, we are actually kind of just deploying this experiment on billions of people, and we're just kind of hopeful to see what's happening. So in that sense, so this was kind of like my philosophical take on this. Uh, of course, I certainly believe that the regulator has to catch up, and the ethical aspects also have to catch up. For instance, one thing to point out is that if, because you mentioned ethical aspects, for one of the active areas of computer science these days, as related to AI, is algorithmic fairness. As we are actually deploying more and more of this kind of decision-making machines in client-facing roles or user-facing roles. It's interesting that, for instance, in US, you already have some aspects of regulation that actually looks into fairness in decision-making with respect to various kind of aspects of our social life. Interestingly, in Canada, we don't have this framework, for instance, right? So you can already see this gap now. For instance, now every regulatory body has to actually kind of start moving to fill in this gap, because, as I said, this is a live experiment. So, like, this technology has already been deployed, and the best they can do is to actually not to stay behind. So they have to catch up.
Why do you think regulators are so behind on framing the ask from AI developers or from companies that have AI in their hearts?
Specific to AI, it's a peculiar thing, actually. I'm kind of thinking about this. Um, I sort of want to again relate it to the comment I made earlier. This centrally important characteristic of technology where it really actually changes the standards uh, as it sees fit, right? So, for instance, you can actually go and read about how I think in Massachusetts or New York, like the Kodak company. Remember the code so was challenged actually legally because uh, people were thinking, okay, can somebody actually kind of take pictures of me on the street with this piece of technology, for instance, right? So the fact, I think, is it might actually have to do with this staggering exponential sort of speed where we are kind of injecting newly emerging technology into kind of product, and then we just kind of inject it into our lives. So of course regulator has to catch up, right? However, the speed is just kind of, it's just crazy in terms of like the way it is, technology being kind of translated to product and then used in our lives.
I share the same sentiment. That the speed of what we're putting out there is out of this world. I've never seen so much concentrated effort on one field that I have nothing in comparison.
Yeah.
Right now, we have so many researchers focusing on AI and machine learning. The big conferences have like thousands of submissions of paper submissions every quarter, and that's only the top ones. You have like 10,000 people focusing on let's say 10,000 of the top researchers in the world focusing on one field. Y- that's gonna have ripple effects to the industry and to the society. Um, why do you think it's the case that AI has so much, let's say, hype from the research community?
uh,
Is it just the interest of it? For sure, I find it interesting. You find it
yeah,
interesting, but is it something else that we don't see?
very good question. Okay, I think there's some parts of it I tend to call the Coursera effect. So I think that effect exists in the sense that at least on kind of on the data scientist part, where there is the interest and people, of course, if you can actually make some piece of science accessible to others, that's great. So I think the kind of largest scale adoption of AI certificate actually contributed to this hype. However, I mean, nobody can deny, like as I said, the kind of miracle like effect of the results of representation learning in image and text domain. I mean, we were all like, I was a grad student in 2015, and then we just saw this, like, it just kind of right in front of our eyes. We saw like this thing uh, kind of came on the scene, right? I mean, these magic like kind of boosting performance for image classification, reinforcement learning, the like text classification, and so on. So I don't, again, by no means I want to discount actually these amazing progresses in these fields. However, maybe I can actually kind of go back a little bit again into my life and actually tell you the story how I again got interested in data science and stuff. I remember in 2015, the last year of my PhD, I read a paper by this famous statistician called Leo Bremen. Leo Bremen, I think, actually is the inventor of random forest. He was a prof at Berkeley, and then he went to consulting, and then he came back to academia. The paper title is Statistical Modeling the Two Cultures, where I think Bremen tries to actually kind of um, make a distinction between the methodology of machine learning and kind of make a in contrast with the statistical kind of methodology, the way statisticians actually approach. So, you have on the statistics side inference, and then on the machine learning side, you have the problem of learning, which are basically just the equivalent words, like, equivalent concepts. At that time, my reading of that paper was that, okay, the hell with regression and statistics, the hell with like hypothesis testing. All I want, and all the single solution I think is worthy of spending time on is building predictive machines. So let's go for actually the most sophisticated ones and see actually what can get the job done. However, of course, this is again pertaining to my experience in banking. Uh, you come to banking, they give you this data and they say, okay, start forecasting for us, for instance. And I'm telling you, I mean, if you're using like an LSTM or a neural network, you're doomed to overfit 99% of the time, right? So then you do these experiments enough times. And if the person is a trained scientist with scientific ethics, they would understand that, okay, there is a limitation to these methodologies when you take them from one field and you want to actually apply them to another field. So I think uh, a lot of hype maybe or confusion comes from transitioning or translating some achievement from one field and just apply it to another field, right? And of course, again, I said, sure, it's super cool to actually take, for instance, NLP advancements from the text domain and apply them in banking and just kind of automate the stuff, for instance, and add efficiency, right? But the claim that deep learning is a universal tool that actually kind of solves every problem you throw at it, I don't see a lot of validity to this, to be honest. So that's kind of my view towards the hype that you mentioned.
Yes, and I'll select something from what you mentioned right now. You're saying that the AI developer should be ethical, should have all this knowledge, and somebody could say that we're putting too much faith into the AI developer, and we don't have the framework around him to kind of limit what he can or he cannot do. In the EU guidelines, something like that was mentioned, and what the 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 reaction was, we need to have a human centric approach, and in trustworthy AI, kind of requires a human in the loop, meaning that somebody that oversees the ML model, the input, the outputs, everything, and it's like an appointed human auditor. Why do you agree with that sentiment? Why do we need this approach, and have you seen it in practice?
Well, I mean, it's a good thing. It's a good thing, I think, in theory. However, I think as a practitioner, the first question that comes to mind is, in a lot of these fields that actually we deploy AI, we want to actually kind of add efficiency. We want to do things at a scale, right? And okay, if you have now this, what does it mean to have this human in the loop? So the human limit, if you're, for example, scoring thousands or hundreds of thousands of instances, like, in every data batch, so it means that the human in the loop also should go over all of these. So these are kind of, I'm not, again, discounting what the EU people wrote. I'm pretty sure they are very respectable scientists, hopefully. Uh, However, the challenges in practice are immense, right? As you are very well aware, right? As a person who actually deals with these things on a daily basis. Uh, but uh, it's important to actually, again, as scientists, I want to maybe just kind of open the parentheses here and say, I think in all of these discussions, data scientists should have this kind of um, implied code of conduct for themselves, and assume that we are actually scientists that are hired by businesses that deal with problems surrounded by a lot of ambiguity and open-ended questions. So it is super important for us, at least, to actually kind of adhere to this code of conduct. So parenthesis closed. So that's important for me as a footnote. However, what I wanted to say was, in practice, limitations are real, but it is important for the data science community to um, to kind of acknowledge this as an open question. When you see that, okay, this is the open question, then you dedicate research efforts to it and come up with methodologies in terms of what can be done uh, to actually kind of incorporate human in the loop. I definitely think it is actually it is absolutely important for various reasons. Maybe the first reason is having the human in the loop basically means that you have enough structure and procedure surrounding the model that you're deploying. My opinion, in uh, almost every case of successful AI model deployed, I see like this tripod of data, algorithm, and infrastructure. So and when you have this kind of three things installed and kind of sufficiently leveraged, then you have like a model that actually starts working in production. And then both like data and infrastructure could actually have could benefit from actually kind of a human in the loop here, both as, let's say, I mean, a subject matter expert that labels your data, or a subject matter expert that actually manages the process monitoring. However, again, there is this problem of a scale. uh, I wanted to point to some of the things that we have looked at, or we are currently looking at, or I'm personally interested in. That's mostly, yeah.
I don't really want to get into the specifics. Maybe you have like a NDA signed. I don't want
Yeah, yeah. No,
to
no,
to
this is
put you
really
in any harm's way. I was trying to look more on your opinions and what you were saying there with that uh, AI code of conduct of the code of conduct of AI people. But right now, this code of conduct is different for each person. There are no really guidelines on how this code of conduct is
yeah.
achieved, and and how we, and subsequently we can't really drop that human in the loop and then scale up. What do we need to go away from this need of overarching like support to the machine learning models, and then continue to scale up and have this trust to the model?
Hmm. Uh, I think actually the finance industry, actually, it's interesting to me, at least, because we already have, because of the existing regulations, we already had this thought about, okay, if a team is actually deploying a quantitative methodology, then there should be an independent body that actually kind of looks at this, right? Although you might think, okay, this might be time consuming, or whatever, but still this structure exists, right? So for finance people, we already have this, or in the banking, we already have the structure. Now what we're thinking about is, okay, so the current guidances we had for actually these overarching principles was for, let's say, I don't know, statistical models, or I don't know, time series models, forecasting models, and stuff like this. Do we need to actually think about adding new principles to cover these new generations of models? So in that sense, I think things are a little bit better for doing foundational work, for building on basically these existing principles, and actually kind of um, and update them, maybe, and extend them in some cases to encompass the new use cases. However, I want to also say a lot of these stuff are, again, um, context specific, right? When you can, for instance, have models that are deployed in low latency mode, high latency mode, right? I mean, there are models that maybe you deploy like once every month, once every quarter, or you have, for instance, in the algorithmic trading space, you have like models that are, I mean, the millisecond execution, right? And so in that sense, um, the technology and methodology, I think, depends on the context. The point that I wanted to allude to, one of the things I find very interesting on the research side is the, not the emerging field, but I want to maybe call it emerging field of AI verification. So this is mostly this area has mostly its roots in control theory, where people actually kind of were thinking. I mean, I don't know, 60 years ago, the rocket scientists, but they had to deal with a lot of these problems, like specifically robustness, right? And making sure that actually your models work under realistic types of perturbations to the system. So I think, at least in the field of reinforcement learning, people have started thinking about actually kind of coming up with the principles where would enable us to uh, start with a human in the loop, Okay, but kind of run a system in parallel with, let's say, the RL model, for instance, so that actually it runs these checks kind of on a continual basis, right? And then kind of gives the red flag if actually things kind of start breaking down. So uh, maybe this is something actually to look at. My thinking is maybe some of the methodologies could be actually borrowed and applied to other types of ML models or model uses. Uh, but in general, I think this is a really open question.
Yes, it is an open question and it's a very interesting question. And as you said, probably there is not one size fit all, but we have to find a way to have some generic guidelines on what we should or shouldn't do in the AI field and AI deployment. And one of those things is recently has we've seen a shift from focusing on the machine learning aspect of the models towards the data aspect
Mm,
when it comes to understanding the ethicality or all these the fairness or all these notions that we were mentioning before.
mhm,
One famous example is that one image classifier was suggesting that Barack Obama is a basketball player because only
mhm.
black people, the only black people in the data set were basketball players.
Yeah,
Do you think that the data should play a bigger role than they do right now?
yeah. This is a great question. It reminds me of actually a recent article I read, and I think one of these blogs. I think it was the Gradient. Gradient also, by the way, to ML people, it's a good place. I usually hang out there for good papers. I think the title of the paper actually was "The Clever Hans Moment Has Arrived for NLP." And what they were actually arguing was that, look, a lot of these state of the art models or algorithms that are being published and they're kind of being accepted on various conferences. There's too much emphasis on the algorithm. Let's also spend some time on these benchmark data sets that we have. Um, Absolutely, for sure. I think again depends on what you want your model to do. Let's say just you're only focused on the performance. Um, let's let's forget about like fairness or everything. Let's say you actually have an optimization objective and you just want to minimize that optimization or optimize for your required performance metric. Maybe you want to basically look at your data set and see, okay, I want, okay, there are meaningful signals in my data, so, and these are basically the features or the underlying features that you want to learn, but maybe you want to filter your data and get rid of like the noise or the kind of associations or correlations that are very brittle, right? So this is actually again related to adversarial kind of training of your models, right? You have your data set, but you don't want your model to pick up every signal possible, right? You want, especially like the neural networks. I mean, these are very high capacity model. They latch on every kind of signal that they can latch onto from the data. So um,
Yeah, you
so
don't
often,
you don't you don't want to make decisions based on, for example, if you're trying to understand what kind of animal I have in front of me, you can't really pay attention to the background. If it's a field, then I'll predict that this is a horse, or if it's a house, oh, this is a dog or a cat, right?
yeah, absolutely, exactly. So um, I think generally a series of tests that actually are also introduced in that paper that I referred to. Um, that I like. These are very simple in principle. They're called data ablation tests, right? So data ablation basically means that like there are some features of your data. Uh, if you want to see actually they contribute to your decision, take them out and see what happens. If that piece that you're taking out, uh, if you're taking it out and the decision doesn't change, it means that okay, this is extra, just throw it away. But if for instance, if it's something meaningful and you're taking out that, then your model should behave the way you want it to behave, right? So this kind of, again, these are sort of ad hoc tests that you need to do your own model, and they're very specific again to the domain you're actually kind of working in, right? Depend like for NLP tests, you might be able to design a specific ablation test for tabular data, some others, but I think we should be kinder to data for sure. Uh,
You mentioned ablation. Are there any other possible ways that we could leverage data in understanding, especially the model output?
So this is actually one thing that I think both you and I have thought about and spoken about is the counterfactual understanding of a very complex model. This actually again brings me back to the paper by Breman that I quoted when he actually says that machine learning models in essence are black box. Just accept them as black box and understand what you want out of them, which is just the most accurate prediction. Okay, so if we understand machine learning models as super complicated black box models, again, and think about it as a model validator, like I am. Uh, One natural way to actually approach the problem of understanding the behavior of the model is through counterfactuals, right? So you have like the specific given point X and Y, right, sampled from some distribution of your input output, and then you have like the behavior of your model which is fitted to this data. Then you want to say, okay, well, what's going on if I change some of these, right? Of course, you cannot just change randomly, right? I mean, this is not feasible, but maybe in an optimized way, right? And again, this relates to actually this adversarial machine learning or adversarial perturbations, where in general, actually, one way is to accept so the model as the black box. We don't want to actually open it, but it's still through the associations of X to Y, we want to understand actually, and based on the distribution we have in our trainings, that we want to understand the relationship that this function builds between X and Y by crafting new X's and see actually what happens in the worst case performance, right? So adversarial examples basically, in essence, have this effect, right? So you design perturbations, or at least you look for sort of perturbations in the input space, and you want to see to what extent you can actually sort of exert these perturbations to your trained model and see what happens in the worst case performance, right? So again, these are ideas that actually come from image domain and in fact from AI security and cyber security. But of course, you can take them and look at them from the algorithmic point of view, from the modelist point of view.
Yeah, and to give to the audience a bit more on what a counterfactual is and what is an adversarial example. An adversarial example could be I have a classifier that labels a picture as a dog, and the same picture after I put some noise. Let's say I make a small hut, a very small hut that nobody can see it on top of the dog's head. Magically, right now, this classifier labels a dog as a cat, and that small perturbation is Ali said, might not be a high. Usually, it's not a high. It's some white noise, but I'm just saying that for the sake of understanding that we can there are examples that you can put that you can change the image in very little, and then you can change the outcome of the classifier. And a counterfactual, it is exactly what it means. You have an example. Let's say uh, the dog, and a counterfactual would be that and a statement would be that the algorithm, the model itself, understands that a dog has four legs. And if you put that picture with a dog with five legs, this will not be classified as a dog. It should be classified as something else, because your hypothesis is that dogs have four legs. I believe that adversarial attacks and adversarial learning uh, could benefit us more than that we can use more in our everyday lives and machine learning. Um, do you do you have any ideas on how we can more we can leverage adversarial learning in the future?
Yeah. Okay. So maybe actually again reiterate that this entire adversarial ML actually grew out of AI security space, right? People were actually thinking, okay, I'm going to build this autonomous driving car, and is it possible for other people to hack it or like manipulate it? So I am thinking of it a bit differently from a person who looks at a model or an algorithm and looks for its vulnerabilities, right? That's the job of a model risk officer in a bank. Um, so one thing I mentioned was if I'm deploying a model, I think it's in principle it wouldn't hurt for me as a model owner to understand where these adversarial points are in general, right? Although it might be that the model I'm deploying is not an autonomous driving car. It might be actually an NLP model, right? I mean, adversarial examples also exist for text, right? They are actually, I mean, even for reinforcement learning, for almost every area where deep learning had some success, I think actually adversarial examples also popped up, right? So I mean, maybe very naively speaking, yes, it's good to actually first understand these and see for instance, as a first step, if we generate those, but I mean, there is a zoo of different methods for generating these examples for a given model, right? It's good to understand what regions they are located at, for instance, right? I mean, you want to understand some of the statistics of this. You want to build features out of this, right? Just list them out and see actually what are the common features you see, right? So you want to understand the local behavior of your model, right? These are, I should say that the type of analysis you will do with adversarial perturbations is local, right? You already have a point and you understand this point is mapped with your f hat, the model you have trained to y. Now you want to understand what is going on around this neighborhood, right? So this is not a global analysis, really just a local thing. So in that sense, it's a good way of understanding what's going on around a given point for your model. You also mentioned adversarial training, which is another way of looking at this. So suppose like you have this model and then you generate all of these examples, adversarial examples, that basically are designed to fool your model, right? So the label your model assigns to them is kind of, you should flip them to make them correct, right? By making some assumptions. Let's say you add all of those to your training data now, right? And then you retrain your model. In essence, this is called adversarial training. And I think actually the effects of this type of training on larger scale neural network models is still an open problem. We don't understand actually a lot of the behavior that emerges. But one thing we have observed is that it makes them more robust, for instance, right? So this is one thing you understand. But also in some of the empirical results show that it also makes them it makes them less accurate, right? So you will get this accuracy robustness trade-off here. One thing actually that seems interesting is, however, something for maybe the data scientists to play with is if usually labeled data is very scarce in machine learning, right? So maybe something to consider. Or maybe some kind of directions for experimentation is, okay, if I have like a very high capacity model and maybe not enough data, maybe I can actually do adversarial training for my model to train harder on this small data set. Of course, one should also be aware of like the kind of biases that this introduces. So it's not off the shelf implementation, but this is something I think worth considering and maybe exploring a little bit. So this is one of the applications I'm very excited about. Like you have a small data sets, you have large algorithms. Can adversarial training help you train kind of better on these small data sets?
Yeah, that is great, and I can definitely get by that statement. And that is all. Thank you, Ali, for helping me back up our minds.
Thank you very much. Thanks for having me.
You can follow Ali on social media. You will find the links in the description below. And have a great summer.
You too, man. Thanks.
This is it. Your mind is now backed up. To learn more about the topics discussed or the guests, follow the links in the description. Now you have the chance to subscribe, rate, like, dislike, and review the show. Also, looking forward to hearing your thoughts in the comments. Awesome. Thank you so much for joining me, and see you next time.